I'm currently monitoring my live stream right now, which means I had to tune into my own live stream to check out if something goes right or wrong. And the account that I'm using does not have a YouTube Premium, and ads obviously shows up. And the first ad that I got was Fortnite, and my day was ruined already, even before the stream has started. Speaking of YouTube Premium, I there was a chance that I could subscribe to YouTube Premium feature with a slightly cheaper than the normal default method of joining the YouTube Premium directly via YouTube. And this is I was able to do that. I was able to subscribe to YouTube Premium feature with a cheaper price, with the affiliation of my phone's network service with the YouTube. Yeah. So basically, very interestingly, my new phone, which I got last year, I was able to like select some services with the internet plan that the phone service provides, and one of them I had the ability, the feature to connect with the YouTube Premium itself. So basically, it's providing the internet and YouTube Premium at the same time. But it's an affiliate. The network service provided a YouTube Premium subscription fee with a cheaper price than the YouTube, a cheaper price than the default price. And that is fucking no more. Because I recently got a notification that thing is gonna go to shit because of the opinions from the hierarchy have said that shit is no more. Now we're gonna charge almost as the same or even expensive, and that's going to be it. I don't think. Yeah, obviously it's not going to be expensive than the price that YouTube provides, but it was. I think it was like almost normal value. This almost the same value. As the direct price from YouTube. I have been using YouTube Premium with a cheaper price with that service, and now I'm deciding I'm not going to do that anymore. Almost 90% of the motive of subscribing to YouTube Premium was cheaper price that I was able to get my hands on, and now that thing is gone. And it's quite hard to maintain the motives to subscribe further on YouTube Premium. And YouTube Premium subscription fee in South Korea, I believe it's the price, the subscription fee in South Korea about YouTube Premium, according to the nation, South Korea might be in top 10 in the expensive area. I'm not sure. I don't think we're in top 1. We're probably around top 10 in the whole country, in the whole world. And if I have to say a lot of deeper, some internet drama, some kind of shit, and it would take some hours, maybe a few days to elaborate. Yeah, I believe it's also connected to the reason why Twitch is now not available in South Korea. You can access it, but the service is not available in South Korea. Wait, can I? Which? Yeah, I can access to Twitch, but it says in here, notice KST from 2024 February 27th. Twitch service in South Korea will be over. Will be terminated. Seek help from the help page or something. That's basically what it says. Yeah. It's all connected, I think. The internet drama, some kind of that shit, all connected in South Korea. I hate it. No one will like it. No one will shout glee and happiness by the fact that, wow, now I'm gonna pay more just to finally watch the YouTube video with my mobile phone screen is off. No one's gonna do that. So this situation sucks, really. Okay, anyway, now we're gonna go into the thing that we have prepared. This time I don't have a food. Well, I will prepare food in the further into the stream. The reason why I don't have food right now is because, well, I actually didn't have much time to prepare for it. But that's not important. What is important right now is that the equation that you're seeing right now, it is quite intimidating if you don't know what I'm doing. If you know what I'm doing, well, it is still intimidating, but that would not make much difference. So you just have to suck it up, and then you'll probably see things more clearly. And when it comes to clearly, it defines that this actually follows the elliptic integral, some kind of that shit. And I'll explain you how to do that. And I actually have done this. I have done this in the off stream. Like I said in the last stream, which was yesterday, I told you guys that I will be doing this off stream, and I did. So I'll tell the progress. Yeah. The integral, incomplete elliptic integral of the first kind was the main goal that I was gonna go to. So I was about to turn this equation and try to simplify it into like this. So separate this one to omega squared k squared minus omega squared k squared, and simplify that. Okay, and it will turn into something like this. And I had this idea, but ignore this for now on the side. And the next slide. The further simplification, to make this possible, I had to separate this whole polynomial on the square root into the equation of the sine phi. So as you can see, I've separated them. This is the constant. This is the component of the sine square phi. This is the also. Oh no, this one is the component. This one will be the component of sine square and sine quadric. And I can simplify even further. And substituting this constant into a, I can simplify into this equation. And it will turn into, even simplify further by turning components into b and c, which will turn into like this. And from here, I might use my pen right here. From here, I can turn this up. You have to check. I can turn this up into the elliptic integral of first kind. Is what I thought. That's what I thought. But it doesn't seem like that I can change it into something kind of this form, because there's an intimidating sine quadric right here. So I thought maybe this is not the way that I should go for. So I searched it up on Google, and I found out. In the normal pendulum, the integral elliptic of the first kind was the thing that we had to go through. But in this case, there was something similar, which was incomplete elliptic integral of the third kind. Yes. And this is the third kind. I'm gonna show you right now. Was 1 minus n square b 1 minus k square sine square phi 1 and oh no dv. Yeah, this is the incomplete elliptic integral of the third kind. Basically, it's this component right here is the first kind, but what makes the difference of the third kind is this right here. And let's just say it's just a modulus. It's a component that varies, that separates the first kind and third kind, which is it acts as a factor of adding the source in real life, like in physics, not a pendulum and a smooth elliptic surface, but it adds into more complexity. Yeah, I asked this to ChatGPT and it said it appears in the constraint movement in physics, which is what I'm doing right now. The spinning pendulum on a spinning base. Yeah. But as you can see, if I put this equation under the square root, it will make a form of sine quadric. And if I combine, which is if I multiply the sine quadric with the sine square, then it will make a sine powered by 6, and that is I cannot achieve from here. And that is why I had to define my own custom elliptic integral. So first I thought this is just the third kind, and I went with this, but I further noticed that this is actually not third kind, so I actually made a custom one, which is this. I put the 1 minus n sine square phi under the square root as well, and I just simply added a stroke under the pi of Greek alphabet. Yeah, and there's actually a reason for that, which might be interesting. Well, it might not be interesting mostly to you guys, but hear me out. But okay, this is pi, the uppercase of Greek alphabet, and this is the lowercase Greek alphabet, and we pronounce it pi, right? And this is how Koreans pronounce it, basically the same way, but how Koreans write it. Pa-i, this is pa, this is e, pa-i, pi, same thing. Now here's the thing, you notice this one right here? This is a Korean alphabet. Yeah, it pronounces pube from the pi, from the how we write pi in Korean. And yeah, this symbol right here, I got the idea from the Korean character. Yeah, I had to explain that. if anyone was interested. Well, that's not important. So, it's a custom elliptic integral, and I went with it. And ignore the crossed out part. The next one. Wait, how did I? Oh yeah, okay. So it has a formation of this, and if I make a complete equation under the square root, then it basically looks like this, and it has a constant component of a sine square phi, component of a sine quadric phi, and we can compare it to the original side. Then we can determine the value of the n. Yes, and as you can see, the b over a, same value as the minus and minus k square. C over a is equal to the nk square. So with that information, there's some quite a calculation and approach to this conclusion, which is that t is equals to root of omega square minus omega square k square plus g over l times, I'm gonna just name pup. I'm gonna say pup omega square minus omega square k square plus g over l, and there's a numerator omega square k square bk. Yeah, that's how we got it. This is basically the value of n, and like how we got the Jacobi amplitude phi on the normal pendulum, we had to inverse it. The integral of incomplete. The names are so fucking confusing all the time. It doesn't just attach into my mouth. The integral incomplete integral of the first kind. If you inverse it, it turns into Jacobi amplitude, and I thought maybe we're gonna do the same thing. It will yield the same result. And if we inverse the Jacobi, the first kind, it turns into the Jacobi amplitude, AM. And maybe there's something similar that I can change with it. And no, there was no terms for the inverse of third kind. There was no terms for inverse of third kind, which means there will be no specific term for the inverse of custom third kind. Yeah, so I just named it like this. It doesn't matter at all. And the phi is equal to addition over here, which is equal to this, according to the definition we have built in the last stream. Sine theta over 2 is equal to k sine phi. So that's why I wrote this over here. And we switch the inverse of sine, then the sine theta over 2 over k is equal to sine of this whole gigantic thing. And moving further on, can finally calculate the value of theta from this equation, which is I did. And yeah, just apply some trigonometric functions and definitions and all this kind of stuff. I was able to approach to the conclusion that the theta is equal to well, I'm not gonna say the whole thing, but it's basically this whole thing is the answer. Theta is this whole gigantic function. Yeah, it's very lengthy and it's almost very doubtful, like very questionable. Like you might not be sure if Pararang is pulling a prank or trying to trick you or something, because you probably cannot tell. This is just count the amount of alphabets in the function of theta. I'm pretty sure it would exceed 100, but there's so many characters, so many complexity, and even myself, I wasn't so sure about that if this is actually legit or not. So I actually took a screenshot of it, and ask the ChatGPT, what do you think about this? And yeah, the ChatGPT, thankfully it realized that it seems this is a function, the theta is a function that would appear on the pendulum with the spinning base. So it realized, the ChatGPT have realized what I was doing. So I was pretty confident and moved on to the next step, which is the determining the R vector in inertial frame. So first I have to configure the rotation frame of the R vector, which is basically like this. And I think I've done this in the last stream. And the Rx rotation frame value is equal to L sine theta, basically like this. Yeah, L sine theta, and the Z value is equal to minus L cosine theta, which is right here, and this is L sine theta. So that is why, that explains these values right here. And of course, they do spin. Those are the, or what are the actual names of those? Rotate frame vectors, rotate vectors. Anyway, yeah, they do spin, which I can substitute the EX vector and EZ vector into these two right here. The EZ vector and the unit vector of Z is the same because the EZ doesn't change, but EX does do spin. So that is why cosine omega t I plus sine omega t j is right here. So this is the R vector of the inertial frame. Is equal to L sine theta cosine omega t I plus L sine theta sine omega t j minus L cosine theta k. And the component of the I is equal to Rx, and the component of J is equal to Ry. The component of K is equal to Rz. And that's the answer. The Rx is equal to this, and the Ry is equal to this, and Rz is equal to this. And I got the answer. Now the only thing that I have to do is just how to plot this whole gigantic clusterfuck. So I took a screenshot of this also and asked the ChatGPT once more if it can plot this equation, and like I expected, it said that you have reached the data analysis limit, and of course there was an option to manually do it myself with the Python code, and unfortunately it didn't seem to go well. Yeah, it didn't seem to go well. I bumped into some errors. Of course, I asked ChatGPT how to solve the errors and how to even refine the code, and this was the result the ChatGPT have provided me. And I don't want to. Yeah, if you're, I don't know how many of you guys are actually excited to see the results. I'm guessing it's 1 digit, maybe even less. But if you're some miracle reasons have some high expectations to it, well, don't, because it's really disappointing, and I'm gonna show you why. Okay, I'm gonna name this disappointing result of 3D Pendulum. Yeah. Oops. Wait, where did it go? Oh, my bad. Yeah, I forgot. Move into a different folder. I believe this is not quite the similar what I had in mind. This is not what I had in mind. This is what I had in mind. Yeah. I don't know. This, well, it doesn't look like a pendulum to me, in my opinion. So there was something definitely going wrong here. There's something definitely going wrong here, and it didn't actually look like the trajectory that I had in mind. Maybe there was something going wrong while the ChatGPT tried to refine the code to make the errors go away, or something. I don't know. But the one thing that makes it sure is that there is no way the ChatGPT will actually do the job of plotting this equation because of the data analysis limitation. So I'm gonna give up that idea. The idea that I'm going for right now is that I'm going to ask ChatGPT one more time. Right now, I'm going to do it. Ask ChatGPT one more time. The fuck? GPT is hot. Oh, okay. Don't worry about this. So, oh yeah, right. I cannot attach files anymore because I already exhausted the limit. Oh, maybe no. Yeah, I can't do it now. I'm gonna do it. I'm gonna do it. Oh, no. I don't know. Hey, can you plot the curve? The equation on the plot is the custom made equation, by the way. And it will say that it has reached the data analysis limit, and it will provide me the Python code again. And I hope that it will yield the result without the errors. Oh. Here's the plot of the 3D parametric curve based on the equations in your image. The Rx, Ry, and Rz components are expressed using custom elliptic integrals and inverse functions, which were computed numerically. Note, there was a warning about invalid values in the arcsine 2kSn term. This happens when 2kSn is bigger than 1, which is outside the domain of arcsine. You might want to double check the part of the equation, or it may require transformation or constraint on k. Would you like to animate this curve as well? Yes, please. And now it will say it has reached data analysis limit. Yeah, of course. Oh. Here's the animated 3D plot of a parametric curve generated from the custom elliptic integral based equations. But I don't see it. Would you like to export as GIF or MP4 file? GIF, please. You cannot just spew bland, straight up lie. Where the fuck is it? I'm not seeing any. I can smell the future. No, I don't even have to see the monitor right now. I definitely know what GPT is going to say, but it won't matter. But at least I got the first image, which was out of my expectation. That's okay. Yeah. So, I'm going to. Yeah. There we go. I'm going to. Oh my god. Oh. Okay. Yeah, what I was doing is for some unknown reason, I don't know if it also happens to you guys, but the Chat GPT doesn't support direct image download. So if I right click this, I don't know if you guys can see this. The first thing that comes up is open image in a new tab, and when I do it, it doesn't open a. Well, it does open a new tab. You probably just seen it for 1 millisecond right there. But it downloads something, and that is not image. It is. I have no clue, but it is not an image. You know what? I'm just gonna screenshot it, and I'm also going to include this in the membership page. Yeah, so I actually had some decent conversation with ChatGPT about what do you mean my equation is not legit, and the most memorable response was that in the provided equation that I have given to the ChatGPT is that it seems like it's well it is it does seems like a helical motion, spiraling helical motion, and it also added that it could be part of the trajectory of the spinning base pendulum. But while I was having that, the ChatGPT didn't provide any visual attachment into it to provide its backup. But that's what it said. And this kind of looked like helical. Well, the long word short, yes, I fucked it up somewhere. But what I'm not going to go again into deeper about like going to back through all the stuff that I've done to figure out what have went wrong. I'm not going to do that. But I'm going to do something else. Just hold on. Just hold on. Jesus. Okay. Yeah, I'm gonna do something else. And what's this one? The GPT also provided its own answer to the problem that we're facing. And if I show this, I actually have that Python file right now, and if I show this on stream like right now, then that will be it. Yes, that will be it. And you have fully fulfilled your expectations, and your purpose, and there will be no any more reason to watch this live stream. It will be just me extending this stream's duration into blubbering degree. So I'm not gonna do that right now. Yeah, even if I do that, it's just so shameful, you know, like unjust behavior. So I'm not gonna do that right now. Well, I will do that in the final I mean, right before I turn off today's live stream. I almost have set final moments, as if I'm gonna die in 2 minutes or something. Yeah, Jesus. Okay. So there was a different approach to this problem. Also, do you remember what I just said? That if I'm gonna die in 2 minutes, I suddenly felt really scared to say that. I know that I just said it out loud from my own mouth, but what makes it more scared and shivering is that I have recently watched a clips of Final Destination Bloodlines. And you know, the franchise, that one franchise that makes you careful at almost everything. And you cannot even take a sip of your water or throw a coin or even just simply spin a coin. Who would have thought that one single coin could brought such a huge catastrophe? A coin was all is needed. That old man from what was the movie? Anton Chigurh. That old man was super lucky, and they didn't know it. The point is it was so shocking. It was so shocking. Also, kind of pretty addicting. When it comes to scary, violent movies, the gore movies, it's disgusting, but it's also addicting. The two emotions are compelling at the same time. Like, you want to repulsive. You're feeling repulsive. You're also feeling towards attracted to it. And sometimes the feeling attracted towards it, and that feeling sometimes works stronger, and sometimes leads into binge watching of the gore scenes of various movie clips, and that is weird. I'm not saying that I enjoyed every single moment watching it. I'm not a psychopath, but it does feel weird, and I believe you probably have some similar experiences with that. Just like as if I want to force myself on believing that I am strong, I can stomach this. Something like that. So the different approach that I was saying about was, what's that name? Lagrange equation? Euler-Lagrange? It's kind of quite similar. Well, you know what? Basically the same thing. What we have done, and what we have already have thought of. And I'm gonna explain. So the Lagrange was L. Okay, and beta prime, and E. No, I think it was something else. Yeah, I already forgot. Okay. Lagrange. I think that's the correct pronunciation. Lagrange. Oh yeah, and by the way, the This is also the result that the ChatGPT have provided me with my equation. Yeah, and this is the refined version. No, this might be incorrect from the one that I have provided. So I think the most recent one that I've shown you guys just yeah. So the thing. Ah shit! I'm gonna start stopping here. Where did I put it? This might be accurate than the one that I just shown you. Yeah, I know. This actually feeds me the feature, the statement that the ChatGPT is not 100% reliable. I know that I rely to this AI quite a lot, but I have to refrain myself overly relying into the AI feature, but I might want to rely on not 100, but perhaps 99 or some value closer to those 99. But yeah, it is T, theta, theta prime, and T, and that theta doesn't actually have to be theta. It is theta in my case, but it can be something else. It depends on the case. So, and this will be T minus, was it V or P? I think it was V. It is V, okay. And T is the kinetic energy, and V is the potential energy. Yeah. So we have already calculated those in the last stream, so it's kind of similar to what we're gonna do. The kinetic energy. Oh yeah. The hold on. Okay, Rx is equal to. I'm gonna copy paste the same thing. L sine theta sine omega t. L sine theta sine omega t. Okay, and Ry equal to L sine theta sine omega t, and Rz was minus L cosine theta. Oh, here goes. Here's something. Okay, it's maybe too early, but I'm gonna take a break. Like I said. Okay, you are not currently watching the same screen that I'm watching right now, but this is what I've done right here. I'm gonna take a break. I think I'll be back in 5 minutes. Yes, it's gonna take a while than usual. But I'll be back. I might have to write something here to keep you engaged. Okay. ER. That's not gonna work. Okay. 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 I don't know if I should be concerned about this. But the side of my left foot hurt. It hurts. The side of my left foot hurts. I don't know if there's like it got have to do with my posture or something, but I actually do have a little bump on the side of my feet, on my both feet, and I actually didn't feel much pain on the side of my feet, but I'm just feeling pain, a little bit, slight, very like negligible pain on my left feet. I think I don't have to worry too much about it, because I believe that it will go away when tomorrow comes. I will try to be concerned about it if pain just still remains even the tomorrow comes. Yeah. Is it because of the size of my shoe? That can't be. Yeah, so there's a theorem, and it's almost pseudo-scientifically proven that people who's kind of tall have huge feet. Yeah, the height and the size of humans' feet kind of relates, and I kind of do have a big feet compared to my actual size. Yeah, I'm actually quite considered as like almost above average. Yeah, I am tall, but I am not freakishly tall. Above average in South Korea. In South Korea, yeah, which is I'm I'm pretty sure I'm going to be considered very short when I go to overseas, especially when I go to the Western area. Yeah, especially I'll be considered very short, even considered as in like gnome level in the West. I am below 6 feet. 5'10", I think. Yeah. The thing is, we use centimeters, unlike some dumb fucking country who doesn't know what a kilometer is. So there's another point. The size of the feet and the height relates pseudo scientifically. But I do have a big feet, unlike my height, and it was kind of hassle, like to find the correct shoe, the correct size of a shoe when I was young, because the size of the shoe for the kids are kind of limited, and they don't actually go to the region of the adults. Yeah, so when it comes to size of the shoe, they make the size of a shoe expected for the children's feet, not the adults' feet. So I believe at that time when I was young, and when I was a Goo Gaga kid. Well, not that much of a Goo Gaga, maybe like in middle school or high school. I the shoe was kind of pretty small. Yeah, the shoe was kind of pretty small. It was not difficult to find the shoe that was actually kind of fit to my feet size. But um, I kind of say, yeah, I kind of had to say that my feet was almost bigger than the average size of my fellow kids, and those were the times. Yeah, the shoe brand option was kind of also limited. Okay. Okay. Wait a minute. Hmm. Wait, how did I do this? Wait, how did I do this? I don't remember. Oh no. RX is that. BX. I have to. Hmm. I might need to write it down somewhere else. Oh. Is this correct? All sine theta sine theta d theta dt sine omega t plus omega sine theta sine omega t omega and cosine omega t sine theta is equal to no. Minus L cosine theta, and if we differentiate this, it will become L sine theta d theta over dt, right? Minus sine theta and L sine theta and d sine, yeah, okay. This doesn't look good. Okay. Vx square. Here we go. Vx square going to be L square and oh my god, sine square theta. You're gonna go first. Theta primes square cosine square theta cosine square omega t. Okay, and minus 2 theta prime omega minus 2 theta prime omega sine theta cosine theta sine omega t sine omega t sine omega t. Maybe there's a way to simplify that, or maybe they're not. I'm not gonna force it. Okay. And what sine omega t sine omega t sine omega t plus omega square sine square theta sine square omega t. There we go. And this will be equal to L square. You know what? I'm only gonna change this one. This part right here is equal to this is 90 divided by 2. Theta prime omega, and there's 2 on the bottom, sine 2 theta sine 2 omega t. Okay, there's a minus in the front. And Vy square. There we go, Vy square. Might be very similar to the Vx square, I assume, equal to L square. And theta prime square with sine square theta. And this one is a sine square omega t. And plus 2 hold on a second. Okay. Well, 2 Okay, Vz square. Simple, which is L square sine square theta and theta prime square. And I noticed these two are the same thing, right? This is minus 2 theta, and this is 2 theta prime omega sine square plus cosine square sine omega t and cosine omega t. So they do both go. Yeah, when I add these two, when I add all these up, they will do go. Okay. Will do go away. vx squared plus vy squared plus vz squared equal to L squared of theta prime squared plus cosine theta prime squared sine square omega t sine square omega t will turn into theta prime square cosine square theta. Yeah. And these both will turn into omega square sine square theta, and the last one it will be theta prime square sine square theta. Okay, and we can simplify this even more, which will be theta prime square. You know what? Now I'm going to just write it into this one. dt d theta square. Yeah, and plus omega square sine square theta. Boom. And this is going to be the square of the v. Yeah, of the velocity. There we go. And this will prove the kinetic energy T is going to be 1/2 m and v square, which is v square is that thing right over there. So 1/2 m L square dt d theta. It might be the same value that I've calculated in each side in the rotating frame. Like, do I have the slide? I have so many slides somewhere over here. Was it this one? Somewhere over here. Yeah. So maybe same or similar value, I suppose. And also we'll be approaching to a same term, like same method. What am I talking about? Oh, it's a different method. A similar method is that what I'm saying, kinetic energy, potential energy, involves those two energies. And the Lagrange equation method, I forgot how it's called. It also derives from the energy conservation properties principles, I believe. So, yeah. Omega square sine square theta. Okay. 맞지 이거? 이번에 good. And the potential energy is really easy. It's the what was the z coordinate? Minus L cosine theta, right? Minus L cosine theta. And just multiply by mg. Okay. Minus mg L cosine. And if we P minus V, E minus V will be ml 제곱 bt분의 beta 제곱. plus mgl cosine beta. Okay. Yeah, so that was the Lagrange. What was it? What's it called? Totally forgot what's it called. Lagrange. Pretty sure it's human's name, like the inventor's name. Okay. Lagrangian. Of course, Lagrange. Yeah. And there was also one more equation called Euler-Lagrange equation, and it looks kind of like this. I'm gonna show it to you right now. Oh, wait a minute, maybe not. I know that I have just took a break like a few minutes ago, but I think I have to do it again, this time for the bathroom. How shameful of me. Yeah, through your rocks, tomatoes. If you're a medieval suit, it's okay. Okay, there we go. Be right back. Whoa, wait a minute, what's going on? Okay. Oh, I just thought that my VTuber water was leaking out or something. It's all fine. There was one time that I was monitoring my live stream while I was taking a break. My VTuber model moved. And that was one of my scariest shit I've ever had in my entire life. And I still have no answer to that phenomenon. I did search a little bit, well, because I didn't much take care about that thing, so I just took a very simple search about that, and apparently some people have similar situations, similar things happen to them also, and it was quite a common thing. I've heard it was the malfunction or the automatic recalibration. And sometimes the camera focus, it alters the footage that's being sent into the VTuber studio, and it sometimes misinterprets as a human facial expression on the screen, some sort of like that. And it was quite an experience. Of course, there was someone saying try to entice into the theory of ghosts, and I'm not buying it. Alright. This is the Euler Lagrange. What's it called? Euler Lagrange equation. Yeah. And we will use this to eventually approach to the function of theta. We'll use this. Yeah. So there might be a whole 70-page worth of progress on how to derive this function, the Euler Lagrangian equation, and I decided not to research that because that would just sidetrack into like significant degree and might never be able to come back. So I decided not to do that. Maybe I'll come back. You know, maybe I think I will not come back. I think I will not come back to the Euler Lagrange equation. Because well, you didn't have seen it. You haven't seen what I was doing off the camera, and this whole giant amount of slides that you're watching right now. Half of them I've done the last stream, but the half of them I've done the off stream, and my brain was boiling with steam as if there's liquid between your brain and your skull, and when it gets too hot, the air bubbles will try to form, and it will expand exponentially until there's a crack and your skull opens up, and the steam will blow out and will eventually inflate your skin layer and inflate the skin until it blows up like a balloon. Did I scare you with that fact? Don't worry, I just made that up. I don't have any medical degree. But who knows? Maybe it would turn out that it's actually not a total buffoon, a total tomfoolery. Who knows? And the theta prime value. Oh, what was the theta prime? Theta prime is the one that we're gonna go for. Okay, so Lagrangian is this shit over here. We might need to copy and paste it. Okay. This is the theta prime square. I have to keep reminding me that theta prime square. The partial differential of the Lagrangian according to the theta prime would be a constant with ml square theta prime, and that would be it because all of these would be constant. But the partial differential of the according to theta, not theta prime, will be this whole section will be constant. It will go away, and ml square omega square sine theta cosine theta minus mg L sine theta. Okay. And if we differentiate this partial this section right here, and that would yield ml square theta 2 prime. Okay. I'm gonna plug it back in. ml square theta 2 prime minus ml square omega square sine theta cosine theta plus mgl sine theta is 0. Hopefully I'm doing nothing wrong here. Is okay, and that is 0. We can divide ml in the whole section, then it would yield ML square will do. Then it will yield theta 2 prime minus omega square sine theta cosine theta is equal. No. ML square plus G over L sine theta is 0. And as you can see, this is no fucking way near the linear ordinary expedition, what's it called, ordinary equation or something shit like that. Nowhere linear. It's non-linear. It is so non-linear. It made me want to create a new term describing that is so not close to being linear. It's frustrating. It makes you frustrated. There's gonna be some tolerance degree that needs to be non-linear. It is possible to be not linear, but there is some sort of limit that I can tolerate, that how much it cannot be linear. And this one, particularly the equation that you're seeing right now, makes me frustrated. It makes my head volcano erupt and the magma flowing down in my forehead. And that amount of the frustration. So that was my own thought that I just had right there. But the thing is, we have to eventually have to solve this into an equation according to theta, with a variable as t. Okay, and we're going to. Wait, what happened to t? Yeah, we're going to do that. We're going to. Jesus, we're going to do that. And I just did right now. It's impossible. The GPT, I also have went through this part in the GPT already before the stream, and it said there's no way of integrating this into the standard integration method. Even when it comes to using the elliptic kind, the incomplete elliptic integral, it will not work. So what would be the answer then? The closest answer that we can get is try a numerical approach is what we're going to go for. Numerical approach. Yeah. I recently have got into a chance to learn about the Taylor series, but I think this is out of the boundaries that Taylor just can't handle. I think. Oh. I'm currently looking at the answers of GPT. Yeah, I'm rewatching it again. And the answer seems like the same. Yeah, unfortunately, I think the answer is the same. elliptic integral third kind. My ass, it's not gonna work. Elliptic integral third kind. It's almost like it's selling to me, selling the idea. And I keep using, hey, you stupid fuck, why are you keep ignoring me? Try this new thing called incomplete elliptic integral third kind, and I keep slamming the door in front of the GPT's face, and now it seems like it's mad, like as if like it's wondering, furious about why I'm not keep using the third kind or whatsoever. But no, like I have already tried it, and it just simply doesn't work that way. Is it? Yeah, it doesn't simply work that way. I already have tried it. I don't want to waste another huge amount of time, not even sure about even if I get the answer or not. Yes, the point is, the thing is right here. Even the ChatGPT cannot provide the exact answer to this. Like I said, 99% reliable. It sometimes, very rarely, makes a mistake, and I have noticed it quite frequently, but not into a critical degree. Very, very, very sometimes in critical mistakes ChatGPTs make, but very less amount of times. But even the ChatGPT cannot actually give the clarified answer that makes you feel the clarity, like makes you feel what's the correct word? Makes you feel high in a non-illegal way. It doesn't provide me the answer of those such. There are two reasons for that. The ChatGPT requires me to upgrade its plan. Yes, it requires me to open up my wallet. Or this one is actually not have surfaced. That doesn't seem like a correct word to say in this circumstance, but I don't fucking care. No, it says that I should integrate it at least one time, then it will be available to turn into a third form. Yeah, of course, cannot be inverted in closed form, can be evaluated numerically, measures the elliptic integral of third kind and general structure. This is the GPT that's saying this matches the elliptic integral of the third kind. And I'm gonna show you the default elliptic integral of third kind, which is right here. This is the elliptic integral of the third kind. So the GPT wants me to believe that this formation and this formation is the same. Fuck yeah. Root of 1 minus square minus I really gotta do this for real. Hold on. I just noticed, and this one right here. See this one, and this one. Actually seems different. This equation you're seeing right now is what I have got. And this one is what ChatGPT have given me. Well, obviously I think the ChatGPT might be correct, because that gave me a method to approach from the Lagrangian. Or this one, I don't even have no fucking clue what I'm looking at. But, okay. Okay. Hmm. Well, hey, how did it do it? Hold on. So that thing. Multiply both sides by theta prime and integrate. Very amazing. Okay. Like I mentioned in the last stream, my brain already has reached the data analysis limit even before today's live stream, because I was cooking so hard. I spent so many hours on this. I even slept not that much long for today. Yeah. I know I went to sleep kind of very late after the last stream. But I didn't woke up that much late after that stream. Like, I think I woke up like 4 hours later or something. Because when there's something that keeps bugging your mind, it's really difficult to get it out of your head. Unless it gets solved and is completely clear out of your sight. That's the thing. Okay. And we integrate both sides, which will yield minus it will be square theta. Omega square. And minus G over L cosine theta will be 0. Yeah. I just integrated it. Okay, let me note that integrate. Okay. which will turn into the prime dt over d theta equal to. Oh, did I say dt over d theta? I'm tweeting. D theta over dt is equal to root of sine theta minus omega squared cosine squared theta. I think this is what it reminds me to go for. Yeah. And the progress afterwards would be the same, which I really do not want to do it anymore. Surprisingly, I have reached to a point that now handling with the incomplete integral of elliptic that thing is starting to wear me off. I'm starting to have enough of it. It has been like 2 weeks since I got introduced to this knowledge. And it's already becoming old. Such a sad way to interpret the mathematics. I'm gonna cry. Such a sad way. Wait, how did I do this? Okay. Reciprocal. dt over d theta. It's basically the same thing. Okay. And there is 1 over it. Let me double check if I am doing this correctly. I'm gonna see. Oh, wait a minute. Oh, I completely forgot about the constant. That's actually a huge, big mistake. My bad. Constant. I integrate it and it will turn into a constant. Name is C. And this would be plus 2C at the end. Okay, 2C. Plus 2C. And the reciprocal of that thing would be 2C. And I think the rest of it are the same, right? There are 2 alpha. What is the alpha? Beta. Oh. It says sine square theta here, but there is I have cosine square theta. Of course. Wonder of mysteries. Why do these things keep happening? Okay. Did I mess up somewhere? Wonders of mystery. Minus integrate with differentiate, that would be sine theta minus sine theta. Yeah. Is it plus in the no? theta prime is equal to root of 2c plus 2g over L cosine theta minus omega square. Whoa. Something ain't right. Something ain't right at all. Omega square sine theta. Multiply both sides by theta prime. Integrate. Oh, I think this is not correct. I think GPT made a mistake here. This is the after the multiplication of theta prime and integrated. But if we differentiate this side over here, you guys can see this the cursor. If we differentiate here, it will yield. The 2 will go over here, so it will go away. But minus omega square sine theta, cosine theta, and theta prime. So minus will be in here instead of. I mean, yeah. If we differentiate this, minus will be in here instead of plus. So the cosine will be the correct way to interpret that. I'm gonna do a thing called GPT, you're fucking stupid. So what I'm going to do, I'm going to copy and paste this. See if GPT actually made a mistake here. I think it needs to be cosine square instead of sine square. Cosine square instead of sine square. You know what? I'm gonna double twist it. I'm gonna ask, why is it sine square instead of cosine square? Maybe then GPT will figure out something's going wrong. Okay. I'm not frozen. Okay. Why is it sine square? Why is it sine square instead of cosine square? Excellent question. You're asking why the energy expression with the rotating pendulum uses sine square instead of cosine square in the rotating term. Let's walk through it carefully. Full derivation from the Lagrangian. Okay, it comes from translational kinetic energy, potential energy, total energy conserved. Wait a minute. Total energy, E is equal to T plus V, 1 over 2 ml square. That thing. Minus mg cosine theta. Divide both sides by ml. Okay, and it will yield a constant. Wait a minute. Huh. This guy is actually flipping me off. How dare it? How dare it? Oh my god. I'm genuinely getting frustrated right here. It's becoming like less reliable to GPT, and I don't know if it's becoming a good thing or not. And 1/2 ml squared theta prime square. Okay, total energy divided both sides by ml squared will yield that. B. That's why the sine squared appears. It came directly from the kinetic energy from involving rotation. This term accounts for why not cosine. If you mistakenly use cosine squared theta, you'll be implying that the radial distance of the pendulum swing around the rotation axis depends on the vertical component. What the hell are you saying? If you mistakenly use cosine squared theta, you'll be implying that the radial distance of the pendulum swing around the rotation axis. Radial distance of the pendulum swing around the rotation axis. And some vertical component, which is incorrect. Summary. Hmm? Oh, I'm gonna ask this one more time. If we multiply this, if we multiply this by d theta dt d time multiply by d time and integrate. Wait a minute. Wouldn't we get the same thing, but cosine? Am I wrong? Am I? You're so close. You're asking if it's from the equation of motion, and multiply both sides by theta prime and integrate thus the rotational term integrate to that or that. Let's walk through it step by step and resolve the confusion. Yes, please. Start with the equation, and then over there, multiply both sides by theta prime. Then that. And wait a minute. Gotta make sure if this ChatGPT AI is not pulling a trick on me. Okay. Is it the same thing? It's the same thing. Okay. Left hand side. We have that. And first term on right hand side is, yeah, I understand that. I understand that. Okay. Second term on right hand side. Here we go. Notice that it's the derivative of sine squared theta. Okay. dt over d sine squared theta. 2 sine theta times square prime. And yeah, okay. So why not cosine theta? Why not cosine square theta over in there? Because we need sine squared theta, not cosine squared theta. The cosine form would only arise if the cosine form would arise only if the expression were minus omega square sine theta cosine theta, which is not. So the only difference is that this shit had the omega square sine theta cosine theta on the right side, which is way beneficial if it turns into sine theta. But in my case, it was in my left side. So the cosine square theta is valid. It is valid. If I try to change it, into sine theta and over there, 1 minus sine square theta minus omega square, then it will be, there has to be omega square at the end, and maybe that's where the constant comes in. I don't know. Final integrated result is exactly correct. The minus sign on the sine square theta. Okay. The reason using chain rule was great. Just a slight slip in picking the wrong anti-derivative form. Oh. You know what? I'll play our game. Let's change up the process here and like this. Oh, and by the way, I am finishing this today. The 3D pendulum thing, it will be ending today. Next time it'll be a different thing. Different subject. Different head boiling subject that will make your mind go boom. It will always be amazing. Okay. Prime. Theta 2 prime is equal to minus e over L theta prime sine theta plus omega squared theta prime sine theta cosine theta. Good. And now we will integrate this into here. Integrate. And then will be not this one though. Nothing else. Oh, not this. No. Just cosine theta. Sine theta. And omega square theta prime sine theta cosine theta. Oh, omega square sine square theta. Yeah, okay. Omega square sine square theta. If we differentiate that, there will be 2 omega square sine square cosine theta, which is not right. So I'm gonna divide by 2. If I differentiate that second part of the right hand side, it will be omega square sine theta, and theta prime, of course, at the end. And that's correct. Okay, we have that, and the theta prime we can now finally calculate into the correct term, which I also believe what I have also right was correct, but I decided to follow the GPT's direction just in case to make it sure. Sine. And there's a constant at the end. Constant, of course. Okay, and we have it. We have it. Here we go. Excuse me. Oh god, these all brain activity makes me go famished again. Hmm. Okay. And according to GPT, this follows the form, the structure of the third kind, pi, NBK. Of course. Okay. What did it look like? The just in case, I'm gonna leave some thing up here. Yeah. Okay. I was about to do another alphabet to become a constant, but the more constant alphabet there exists on the equation, the more complex it gets, more confusing. I have to memorize all what kind of contents, what kind of the alphabets and numericals means, and you're simply substituting two emojis like this one right here would make the confusing value go down. Oh, that's why I'm doing this. 1 minus n sine squared b. 1 minus n squared b. And there is 1 minus a squared sine squared b. Okay. And there is the d theta. No, d phi. And this is third kind, NBK. Okay. How do we make this possible? Good question. So, first I really want to do something called a substitution, right? I want to substitute cosine theta. No, sine theta. No, cosine theta. No, what should I do? Sine theta. Okay, let me do this first. This one over here. I'm gonna color you a different color. My stomach just made a very concerning growling noise, and I hope you guys didn't hear that. Thankfully, my microphone quality is not that much good for you guys to hear every noise coming out from my body. Have I mentioned? This is really old news. I got this mic, and the mic that I'm using right now is actually used, and it was sent back to the factory and came out again. That is what I'm using. There was a specific word for products like that. Was it reproduct, remade, resend, recall? Well, for the cars, the term recall was frequently used, but I don't think recall is used among the microphones or small components. But yeah, the word recall for the microphone, small electronic parts. I am using that one. Unfortunately, I cannot tell any difference between the real fresh out of the package and the renewed one. because I have never ever had a microphone the bought directly from the store. I have never bought a unused microphone. The microphone that I'm using right now is used and went to factory and came out again, and that's the first microphone that I'm using all my entire life. If I have to be really specific, the microphone, the first microphone that I got into my hand was the microphone from the earphones. Yes. So if you're watching this, I hope you're old as me, like ancient, like dinosaur level, and you'll probably remember that there was no such thing as Bluetooth earphones. There were only earphones, which is, it was connected by line. Crazy, isn't it? It's connected by cables, and you have to manually plug it in into your phone or computer whatsoever. And in that earphone, sometimes it came up with a microphone feature. Yeah, there's like a small plastic part in the midsection of the earphone cable. Sometimes there's also a button that can act as a... I don't know. I have never got to the feature of knowing what the button do. When I plug it into a phone, that button will have a feature of playing and pause the music, or getting a call, or declining a call, denying a call, something like that. And there was a microphone on the other side of that plastic thingy, mid side of the earphone. I think that's more than 5 years ago. Amazing. Okay, this will be 1 minus sin squared theta. Square theta, sin theta, plus omega square sine square theta. And I want to erase this root over here, if it's possible. That cosine theta is bugging my eyes out, and I don't want that. I don't want that thing sitting in here. How am I supposed to make that possible? How am I supposed to make that? It will be possible if I make 1 minus sine squared theta into a sine u square. I don't know, sine square u. One minus sine squared theta is now sine square u. Okay, and then sine square u, sine square will be sine u. This will be sine u plus omega square sine square in this case sine squared theta will be equal to 1 minus sine square u, of course. I'll plug it into here, and this will be omega square minus omega square sine square u. Okay, and of course there's a constant at the end. Okay, the omega square plus 2c will be a constant. We can ignore that. But what we cannot ignore is that the omega square sine square u. Square u omega root of sine I'm not looking for the complete kind. Incomplete elliptic integral of the third kind. Okay. What is this? This number n is called the characteristic. N can take on any value, independently of the other arguments. Note though that the value pi is infinite for any n. Okay? I completely know what that means. Fine. Square, 1 squared. Ish. Why this one's a sine theta sine alpha? Rule is ruined. One minus sine theta sine alpha squared. I think that's not important. I think how in the hell? No, fuck it. I'm not gonna even care about this. I'm just gonna ask GPT. It's stupid. I tried. I tried my best. This is as far as I could reach. Okay, what am I gonna ask? How do you proceed? How do you proceed with expressing with incomplete integral of the third kind. Goal: express that fucking shit as an incomplete elliptic integral of the third kind. Step 1. Substitution. Let theta is arc sine u, and d theta is du over 1 minus u squared. I think, yeah, okay, there we go. This also makes me angry. this is low-key tricking you. Like, if you just try to follow one by one step, scrolling it down, and you came to here, oh wait, look at this, it's the step 1, and this might be the first step that I should go follow through. And the result of step 1 says, no, you fucking idiot, this doesn't go anything, this is wrong, and you go to a better substitution. This GPT low-key would fucking you up. And not gonna lie, I got fall into this trap for fucking many reasons, and so many times. And it's almost the same method. Basic traditional method of substituting using the alphabet U. And it's wrong. So here's the better option, and it goes on and on and on. And it's baffling, I gotta say. Okay, so what to say? This is not yet in the form of standard elliptic integral, so we consider a different substitution. Better substitution, canonical for elliptic integrals. Let's instead define sine theta is equal to 1 minus 2k squared sine square phi, and theta is inverse of that. This is equivalent to sine theta is 1 minus. So what are we going here? Substitute into the energy equation. After simplification, you get an integrand of the form. This is the definition of the incomplete elliptic integral of the third kind. Okay, so I was not aware of this. This might be the substitution. The different method of substitution for the third kind. The first kind substitution was the sine theta over 2 is equal to k sine phi. And this is something different. I don't know, maybe it's the same thing. Maybe it's not, but is there something different that we can have? I see. Definition of the incomplete elliptic integral of the third kind. Okay, and so the solution becomes like this, like we have predicted. Oh, I thought someone was outside the door. That kind of scared me a lot. It's 4:40 a.m. in here. What this means: the motion of the pendulum can be expressed exactly as inverse of the third kind. You cannot invert it analytically to find closed formula for theta t, but you can numerically invert it and simulate the motion. Okay, what? So substitution. From the substitution, we got it wrong. Okay. Sine theta is equal to minus 2k squared sine square phi. Yeah, I think that's basically the same thing. The sine theta over 2 equal to k sine phi. I want to find out if it's actually the same thing. Sine theta over 2 equal to k sine phi. Okay, and this will be... Oh, wait a minute. I know how to do this. 2 cosine theta over 2 is a sine b. Okay. And cosine theta over 2 would be root of 1 minus k square sine square phi. There's phi. No, cosine phi. No, fine. Sine theta. Sine theta equal to 2k sine phi root of 1 minus k square sine square phi. And the cosine square will finally be root of 1 minus 4k square sine square phi, and there's a 1 minus k square sine square phi. Okay. And it will simplify. I think it will be simplified into something more. Okay, this will yield root of 1 minus k square minus 5. This not just 5k square. Minus 5k square sine square b. Okay. I was wrong. I'm doing something very stupid. Minus 4k. Minus 4k square sine square b. And plus 4k power by 4 sine power by 4 b and root. And I believe this is the square of the 1 minus 2k sine square b, right? 1 minus k square. Yeah, 1 minus 4k square sine square phi, and there's 4k square 4 sine square. Yeah, okay. So is it the same value that the GPTF said? 1 minus 2k square sine square phi. 1 minus 2k square sine square phi. Yes, it is the same value. Okay. So this is equivalent to cosine theta is that, and sine square theta is that. Okay. Substitute into the energy equation. Like that over there. After simplification, you get an integrand of the form. Of course, why not? No. Sine theta 1 minus 2k square sine square phi. theta plus omega square sine square theta. Why did the ChatGPT say this? I need to be 1 minus cosine square theta. The beta in question is omega square, so it's basically the same thing. I don't know. Will it be basically the same thing? I'm not gonna change it to something else. Or would I? Yeah, I probably have to change my mind. Okay, omega square and 1 minus cosine square. Okay. And the 2c at the end. The ChatGPT said something about the constant. Not yet, but I think I can approximate the. I can actually calculate the value of the constant at a certain point. It's constant, so it's a constant at every point. Okay. So 1 minus cosine square theta. Let's square. L minus 2k square sine square b. You know what? I might have to divide those two. Four g a square sine square b. And plus omega square minus omega square cosine square theta. That's gonna suck. Omega square cosine square theta is going to be, I gotta square up this one right here. So 1 minus. Oh, basically this equation up above is kind of easy. 1 minus 4k square sine square phi plus 4k power by 4 sine power by 4 phi and 2c. Okay. And did I make any mistake? No, I think I did not make any mistake. Okay. Omega square on these both terms are gonna go away. Omega square minus omega square. There it goes. But the other things survive. G over L plus 2c is the only constant. Interesting. And that's perfect. 4 omega square k square, 4 omega square k square plus 4 omega square k square minus I can probably do this, maybe not, k square minus 4g over L k square sine square b. Okay, and we have the power by 4 formation right here, so minus 4 omega square a power by 4 sine power by 4 b is what we can get it from. Okay. Still, I can't believe that it reaches to the third kind form. I'm gonna make an attempt, and I'm gonna scowl at GPT or something for making me get tricked into believing that you're correct. Okay. Oh. I name it D. Okay. My arms are starting to hurt now. Like a stage of tunnel syndrome. Gotta be careful. Okay. Oh, maybe I didn't include. Oh no, wait a minute. Yes, I did. I did include. Did I make? I know what step that I have to go next. But gotta make sure that I didn't make any mistake here. Okay. 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 Cosine 1/2. There we go. D theta is equal to k cosine b d phi. Is correct. And that means d theta is equal to k cosine b, and there's cosine theta over 2, which is equal to root of 1 minus k squared sine squared theta. I mean phi. And I think something makes me think maybe I haven't. I think I skipped this. I think I skipped this when I was doing in my very own equation. Maybe that was the problem. It didn't yield solid results. I think now it's trying to make sense. I don't know. Okay. It's d theta. Ow, 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 ow. Yeah. 2k cosine b. This can also go aside from here, but I'm gonna do it later. Right now. This cosine phi somehow needs to go away. Interesting. Sine phi. Okay. Go to I might want to refine this into different something else. This is going to be just longer. This is going to be 2k in front. That's 1. And cosine b going to be down here. Root of 1 minus k squared sine squared phi. And sine b. Okay. Sine phi is equal to root of and the root of 1 minus sine squared b. And the above is 1 minus k squared sine square phi. This one, of course. Okay. Then this will be e and k 2k upon here. Integral of that'll be huge, literally. With d in the air. Okay. 1 minus sine square phi. One minus sine square phi, and hold on. This can't be serious. We're basically the same thing. Same thing right here. Okay, and minus a square sine square phi minus k square sine square phi minus b over a k square sine 4 by 4 phi. And finally, this one, a hold on. This is very tricky. Minus k square sine square phi. Sine power by 6 and b. Okay. All right. Yeah. And now we're gonna bring up this one again. We're gonna bring this one again. Oh my god. Did I eat something bad? My stomach is like keep craving for my attention. This didn't happen every time. Similar thing happened when I ate the matcha cake with beer, non-alcoholic beer on my birthday last year. I still remember that day. It was like my weirdest birthday I ever had. crazy moment I don't want to experience ever again. But sadly, my birthday comes every year around. Oh, such a tragedy, isn't it? Okay, so these two basically needs to be the same. These two. The ones inside. No. The whole thing needs to be same thing with that one right there. Okay. So if I try to differentiate this with something else, then it will be root of 1 minus 2n sine square phi plus n square sine power by 4 phi and multiplied by the square, right? Okay, 1 minus k square sine square phi is equal to root of 1 minus 1 minus 2n sine square phi. I might have to drag all the way down the left. Down to the left? What am I talking about? Okay. Here. Root of 1 minus 2n square phi plus n square n square sine quadric phi minus k square sine square phi and plus 2k square n. I mean, I want to type as 2nk square. 2nk square. 2nk square sine quartic phi. And finally, minus n square. Minus n what? Minus n square k square minus n square k square minus n square k square sine power by 6 b. There we go. And it's all part of the root. All part of the root. Okay. And I'm going to Jesus. You know what, at this point the answer might be very apparent. I can already see how it's gonna end. But I just want to try my best, without relying on GPT's power. How much my measly brain can go forward without relying on the even more measly AI, and it's testing my might, and I don't want to lose fight with me about myself. You know what? I might have to go through the simplification process first. see. K square. What's going on here? Minus 2n plus k square sine square phi plus n square plus 2nk square n square plus 2nk square sine quadratic b minus n square k square minus n square k square sine power by 6b. Okay. And we're going to do the best thing. 2 root of, oh my god, I think I'm overdoing it. I think I might be exhausting myself, which I'm quite not favor of it. Here we are. Trust be. Sine square phi plus 2n plus k square sine quadratic phi minus n square plus 2nk square sine 4 by 6b plus n square k square and this will be 1 minus. Okay. To make it possible, n square k square needs to be 0. And it already is fucked up. It shouldn't be like that. Great job, me. Great job. Hold on. N square minus n square. I'm gonna simplify that. Hopefully that will yield some different results or something. Okay. Hmm. Okay. I'm bringing up this one here. Oh, okay. Oh, wait a minute. That thing is not also simplified yet. It's okay. It's okay. This thing can turn into root of mhm, 1 plus b over a minus k squared 9 square b plus okay, b minus b. Oh, b minus bk squared. Almost have missed that. Oh. Minus b a where b 1 minus 9. Oh, we did it. Everybody shout hooray. We actually did it. We completely fucked up our time and wasted precious amount of 3 hours. And this is the final result that we're gonna get. k was equal to sine of theta 0 over 2. Over 2, which is constant, but sine the eighth, the component of the sine eighth needs to be 0, which leads to n is 0, which also means that this does not follow the average. The elliptic function, third elliptic function. Well, I had my hopes, and I genuinely had hopes that maybe I was wrong all the time, and this will lead me into an answer and made me dive into a deeper concept that I wasn't aware of until I held my pen up. No, and I think it was just not from the start. Okay, now it's time to be Karen against GPT and yell about you son of a bitch. You actually made me go through all of this with your false information. It's not what I'm going to do. Okay. So how to effectively do that is now our question. So how to do that? Well, I'm just going to simply be asking the thing. You can upload the image. That's what we're gonna do. 뭐야, 뭐 한 거야 방금? A is equal to 2g over L. Okay, it's 2g over L. A is equal to 2g over L. And B is equal to what? 4 omega square k square. Okay. 4 omega k square. 4 omega square k square minus 4g over L k square. Minus 4g over L k square, and D is equal to what? Minus 4 omega square k 4. Okay. I'm gonna import this, export this. What if the GPT says her answer going to be, oh, my bad, and maybe it is not about the third kind. Don't you ever, like, whenever sometimes using GPT, you want to commit the Homer Simpson treatment toward Bart Simpson? Yes, like, I haven't seen much of the Simpsons show, but in my memory, about 80% it was the Homer Simpson strangling Bart Simpson, or sometimes smashing with a chair, which is also a meme. Yeah, but looking at GPT, it sometimes makes me want to do that. Yeah. if it's alive, if it's alive, if the AI robot, the physical being of the AI robot if it's a thing, it's a guaranteed. The Matrix future is guaranteed then. The people will enslave the machines and the rules will turn. It's inevitable. Well, I assumed if it was a third kind and continued with the calculation and led up to this equation. Those two square roots has to be the same value. But if that's the case, the n square, what's the thing? N square k square, n square k square, the n square k square on the sine b side needs to be 0. Which leads to a conclusion that n is 0. I don't think that's right. And I don't think that's right. And help me out to fix the problem. I've done my part. Now it's all left to the GPT AI's thing. You're making a very sharp and insightful observation. Thank you, son of a... And your reasoning is impressively detailed. Let's carefully go through your logic and see where the discrepancy arises. The context. You're trying to match an elliptic integral expression to the canonical incomplete elliptic integral of third kind by comparing the integrand's denominator with that. Your goal is to write something like, no, you son of a bitch. You have told me that the 1 minus n sine square phi is not the part of the square root. Did I ever told you guys that? I think I haven't. Yes, but it hasn't. Well, someone's having a bad day outside. Yes, I can hear some people fighting. Well, if I can actually stand up and what's going on, I can possibly bet on who's winning or who's losing. Too bad I cannot do that right now. So, the The ChatGPT, this shit has told me that the 1 minus n sine square phi is not part of the square root. Yeah, it's doing the same shit again. What happened? Looking at the image. The expression you derived as the radical seems to be polynomial expansion in sine square phi, but it includes the sine 8 in term with the coefficient n square k square. You know that in the canonical third kind integral form, the denominator is at most quadratic in sine square phi, meaning its expansion shouldn't exceed sine quartic in the square root, since each factor is quadratic. So you concluded that for the expression to match, the term n squared k squared sine 8 must vanish, implying n equals 0. That will remove the third kind nature, reducing the integral to second kind or first kind, which contradicts your assumption. This is very good analysis. Let's now explain why this contradiction happens and how to resolve it. Oh. Key insight: the expression you're comparing is not yet in standard form. The discrepancy arises because you're trying to match a fully expanded polynomial with the product form. But when you expand this, it becomes something like that. But I know that is not what I have to go for because that's not part of the third kind. This gives a most quartic polynomials in sine phi, meaning that the square root will contain up to sine power of 4, not higher. So if your expression includes why there's a fire emoji, or you mad, like or you fucking steaming, like, oh, this Pararang dude is so stupid, this brain full of shit, I cannot handle this anymore. Is your like brain like steaming, like fuming your CPU? Is that what's happening? Unbelievable. You're a nuisance. Unbelievable. So if your expansion includes a sine 6b or sine 8b, that means one of two things. You're squaring a product with more than two quadratic terms, meaning it no longer fits the canonical third kind form, or you're attempting to force a match with the wrong form. That's not the case. Why n not 0 is still valid. You're absolutely right. Assuming n equals 0 would eliminate the third kind part, so we must reject the assumption that full expression you're working with matches the third kind form exactly as is. Instead, we now realize the true cause of the higher powers in sine phi. When trying to write the complicated expressions like yours involving multiple parameters and higher powers of sine into the form, you're implicitly assuming that the entire radical structure fits exactly this factorization. But in your image, the numerator inside the radical is already a high-order polynomial with sine 6, sine 8, which violates this assumption. How to fix the problem? Step 1. Recognize the limitation. What you derive is not the elliptic integral of the third kind unless the entire expression under the square root can be factored as. If you see high powers, then either you're looking at a higher kind elliptic integral, less commonly defined. Oh no. Or you need to change variables or simplify the system so that it reduces to a known form. Step 2. Strategy going forward. Proceed rigorously. Start from the energy equation, make a substitution, rewrite the integrand and be using identities. Then you will get an expression like... See this? You just noticed this one. You just jumped from 3 to 4. It's that you'll get an expression like. This thing is even not sure. It's not giving a direct answer. Like, I don't know, if you just do something like this and pull up a shit and maybe flip table, you'll be able to get some good shit like that. It's basically like this. GPT is not fully giving the answer. This is... I don't like this. where the parameters n and k are determined by matching the constants in the energy expression. Final conclusion: the presence of sine 6 and sine 8 in your expression shows it cannot be simplified into a standard third-kind form as is. You do not need to set n equals 0, instead you need to use a more structured substitution earlier to avoid high-degree terms. You're very close. A change of substitution and starting again from the energy equation should produce a clean expression matching the elliptic integral of third kind. Would you like me to walk through the substitution that brings the energy expression into third kind form properly and compute the matching parameters k and n? I can see that even ChatGPT contradicts its own answer. You get expression like this, but this one, the 1 minus n sine squared phi is outside of the root. And like 2 paragraphs before, it is saying that it should be inside the root. I'm not gonna even care about it. We're just... At this point, we're basically looking for cooking book recipes in the fantasy novel. And it might be possible. If you're trying to make a mandrake soup or something, you can do that. But not in this case. It's a real world, it needs to be delicate and precise. It's disappointing. I have to admit, it's really disappointing. Okay. I'm just gonna type yes and find out what's gonna do. Okay. If it says you have reached the data analysis limit, I'm just gonna... I'm not gonna go further. That's it. That's the end of today's live stream. No more further investigate. Perfect. We now have the exact integrand from 4 times p in terms of a new variable b using this substitution. What the hell is that? Okay, it looks like it doesn't always have to be the sine theta over 2 is equal to k sine phi. It seems like k sine phi can also be the same value as sine theta. I see. Resulting time integral. Okay, but the denominator involves that's the square root. So unfortunately, this is not reducible to the standard third kind elliptic integral form. Brilliant speculation. Brilliant. Did I say speculation? Brilliant inspection. Yes. Brilliant. It is so brilliant, it spontaneously made me want to clap. And that was not from my brain's order. It was from my own inner soul. My soul responded to the GPT's wondrous, marvelous answers. And this was so amazing. I really highly appraise this. Okay. Because of the nested square root involving root 1 minus k squared sine squared phi. This substitution successfully parameterizes theta t, but the result does not match any of the standard elliptic integral types exactly, even third kind. So this integral cannot be expressed in closed form using known elliptic functions without approximation or special conditions, exemplified great here, small range limit. Would you like me to numerically evaluate this integral to generate theta t and animate the full 3D motion based on the exact form? Yeah, I think yes. I think that's what I gotta do. Okay. Just go for it. And now is it going to tell me it has reached the limit? Oh shit, where's the rotating pendulum? Except the fact it's not rotating. Here's the animation of the rotating pendulum whose motion calculated second from the electric motion approximates without approximations. The pendulum's angle theta t is computed from the time integral. Yeah. So this animation shows the true nonlinear dynamics of the system. Would you like to adjust parameters like omega, kc, a version with a trail? I'm gonna start a new chat, and I'm gonna ask ChatGPT, if you were the one who were trying to be stupid and try to make a trajectory of a 3D pendulum, what would each XYZ coordinate functions would be? I'm gonna ask that. Okay. What would be? Model of a pendulum with spinning base, we consider a setup where the pivot point of the pendulum rotates horizontally in a circle with constant angular velocity, omega. The pendulum has length L. The pendulum... Wait, is it already stopped? The answer should not be this short. Anyway, the pendulum swings in a plane fixed to the rotating pivot, meaning its motion is relative to the rotating frame. Yeah. We want to find the expressions for Cartesian coordinates, like that, of the pendulum bob in the inertial frame. Setup. Let theta t, the angle the pendulum makes from the vertical, in the rotating frame, where theta equals 0 is the hanging down position. Omega, constant angular speed of the base. For example, the pivot rotates in a circle with radius r equals 0, or we're only interested in the pendulum's position, not the pivot's offset. The pivot rotates around the vertical axis, z-axis. Coordinate expressions. Assume the pendulum swings in the radial direction in a plane that rotates the base. I actually know how to read. I actually have learned how to read I.E. Well, it doesn't matter anyway, because I forgot it like 3 hours later after learning it. Then the position of the pendulum bob and the inertial coordinates is... We already know that. Intuition, the pendulum makes an angle theta t with the vertical. Its projection in the horizontal plane has radius L sine theta t. That horizontal direction rotates at angular speed, hence the cosine and sine. The vertical position is simply minus L cosine theta t. Dynamic bonus. The equation of motion in the rotating frame, neglecting Coriolis and centrifugal forces, is that, but if you want to include the effects of rotation, non-inertial frame, the dynamics become more complex due to Coriolis and centrifugal forces. Let me know if you like the equation of motion in the inertial or rotating frame, or simulation or animation code using these coordinates. Equation of each... Have you ever had an experience mosquito assaulting your ear? There were some moments that bugs tried to turn against me and tried to make me bite my dust, but this was full assault, like as if the mosquito was from the medieval times. If that mosquito was from medieval times, the mosquito probably had a spear, javelin, and like full march towards the like castle wall or something. I was genuinely scared. That was the loudest buzzing noise I have heard in my entire life. It was literally like flick of a second inside my ear canal. I can probably be certain about that. Jesus. Okay. Equation of each coordinates, including Coriolis and centrifugal forces. Please. To derive the full equation for the coordinates of the pendulum with the rotating base, including Coriolis and centrifugal forces, we will use the rotating frame. When the pendulum swings in a plane attached to the spinning base, include all vicious forces that arise due to non-inertial nature of the frame. System setup. The pivot rotates by the vertical axis. Yes. I'll skip through. kinetic energy, potential energy. We already have done that. We are like seeing this a million times already. Centrifugal potential. What is this? This arises from the rotation of the frame and angular velocity. Okay, Coriolis is first term, non-conservative. Coriolis effects are handled by adding generalized forces in Lagrange's equation, or modifying the Lagrangian using. So the effective Lagrangian becomes that equations of motion. Using Euler-Lagrange equation, we get that is basically nothing. And the Vt equation. What did they define Vt in here? Vt azimuthal angle is measured in the rotating frame. Okay, omega t. Okay. We Once you solve the above system numerically for theta t and Vt, plug into those. These include all effects: gravity, swinging motion, centrifugal deformation, and Coriolis precision. Would you like a Python simulation for this pendulum, solving the ODEs numerically and plotting the path, or animating? Animate with rails, please. And this definitely will give me a result that it has reached the limit of data analysis. Yeah. So it is certain. It is clear that I won't be able to progress further from here. But at least I can show you that the file that I mentioned earlier, that if I show this, that there will be no purpose of watching this anymore and you'll close off this immediately. At least I still have that. And even right now, it looks like GPT is trying to provide me as much as information as possible. Okay. Python code. Let me double check the things if I am currently sharing the same result as the GPT is showing me. Yeah, I think it is. Yeah, and right here it says it's a b prime square. So I was a little bit confused because in the calculation we didn't much like care about the function of b, but it turns out, yeah, b is the what's it called? Azimuthal angle, basically the omega t, which is it's omega. In rotating frame, it's omega. If we differentiate that by t, it will be the component of the omega t, which is omega omega square. So this one is called omega square sine square, which is basically the same value that we have right here. Yeah, right here, omega square sine square. So I was a little bit confused, but I think it's basically the same thing, right? Effective Lagrange, yeah. Theta, MGL cosine theta. Oh, there is one more thing, I suppose. T minus B minus E. Centrifugal potential. Didn't I include that? Centrifugal potential. E minus centrifugal potential. Oh. Anyway, okay, Python code. I'm not gonna do any more like searching, searching or continuing from here. I had enough too much. My stomach has been growling like non-stoppable for past 5 minutes. It's a signal. I think it's my own body sending me a signal. Stop this stupid shit and I don't know, drink some water or something. I feel it. Okay. It gave me a Python code. Edit in the memo notepad. This wait a minute. I want you to see what I'm looking at right now. There. You're seeing this. I don't think Wait, hold on. This is center of the origin, the x and y are 0, the center axis. Pendulum on a rotating base. I think this is not right. I'm not gonna. Yeah, I'm not gonna input the files of this one. This is totally incorrect. Alright, any error? No. That was totally incorrect, which also makes it add the questionable value into here. It becomes uncertain because the result is fucking incorrect. Ow. Okay, now I really gotta wrap it up really quick. My stomach is killing me for some reason. So what did I eat today? Okay. So I actually have a file. I can go. And this one that I mentioned earlier, the file is actually this. Yeah. So this is most accurate, the one that I have in mind. Yeah, I already have. Well, this is what I had in mind for initially, with the third leaf shape instead of four leaf shape. Yeah, because I thought the four leaf would be easier to do because it has a direction towards to the each axis. But yeah. So this is basically what I had in mind to become possible. I was chatting with GPT and somehow I was able to get this result thanks to ChatGPT. Also 1% thanks to me, please. So, I'll upload this in the post, in the YouTube community post. No, you know what? I think I won't. Yes, just I don't know. I will not upload this into community post, but there's no but. There's only results, and holy shit. Okay, I'm really gonna wrap it up, and I'm gonna do what I have to do. Like I said, in the membership, the files that are accessible in the membership. What did I eat today? Did I eat laxatives in my mouth or something? What's going on? Okay, I'm gonna be serious. I'm going to say some things about the membership. Yes, you will be able to gain the access to the files that were being shown or used in each live streams. So if you're interested in joining my membership and gaining access to those files, please consider joining my membership. Okay. So we've made an attempt. I've also shown you my very own results without help of a little bit help of GPT, but without totally relying on GPT. Yeah, which was the I want to show this image one more time. Where did it go? Yeah, this. And well, even though it is not quite what I had in mind, but I was kind of able to do it without help, that much of a help with GPT. And I'm gonna put an end to this adventure of trying to get a trajectory of a 3D pendulum. Yes. So, that's it for today's live stream. I gotta figure out. Ow! I was really hurting. Yeah, it seems like I accidentally ate like staplers when I was asleep or something. It's very weird. Okay, I'm really gonna go before I make it even weirder. Okay, that's it.